teaches classes here on climate law and land use regulation, and an awesome course that goes through the fascinating and perhaps, I guess, a little bit depressing permitting process for Lake Erie Wind. And we certainly love having an alum like her back to do that. So I'm going to turn it over to Beth and our second panel.
Great, thank you, Jonathan. Good morning, everybody, and it's a pleasure to be here with you and to have a all-star panel here. I'm going to introduce them and then we will launch the panel. First, Professor Robin Craig, University of Southern California School of Law, whose title is I Specialize in All Things Water, but also has a PhD in English literature with a specialty in how English Romantic poets use science to explain social change. So I think we'd like to hear a little bit about that also. And Professor Annie Brett, University of Florida School of Law, who works on ocean policy and is also an accomplished mariner and the youngest female vessel captain to operate in the Pacific, and still going on ocean expeditions. So, also, we are fortunate that we have the technology when the airlines fail to bring Sheila Olmstead, who will be brought up on the screen when she is speaking, but is listening in now, from the University of Texas School of Public Affairs, and also a fellow at the Resources for the Future, who will be talking about her work on the environment and resource economies. So thank you, panelists, and I think we'll start with Professor Craig.
All right. Well, good morning, everyone. My thanks to Jonathan for inviting me to be here. This has been a very illuminating conference so far. So I'm going to talk about has the time come to distinguish between Section 402, the NPDES permit program, and Section 404, the dredge and fill permit program or wetlands permit program, depending on how you want to look at it, and can the agencies actually do it? And so just a starting note, when I first proposed this topic, I thought it was going to be a hardcore administrative law riff on what you can do in the wake of Maui County. But I think the Supreme Court is about to do the heavy lifting for me, so I will be focusing on Sackett as well as Maui County. So why even think about separating the permit programs legally? I am a 402 fan, I will say that from the get-go, and all of the WOTUS litigation has been putting pressure on the 402 program in ways that upset me. So that's why I came up with this topic. But the two permit programs actually came in the drafting history from different places at different times. Section 402 was the pollution control problem. Buzz emphasized wanted to get a handle on pollution control, and they actually resonate in very different legal webs, if you think about it that way. So if you think in terms of what does 402 stop, it really protects the public against bad actors, against polluters. It protects the public interest, resonates with public nuisance, protects aquatic ecosystems, protects against private nuisance, protects those public use aspects of waterways, and it really is hard to frame in a negative connotation when you're thinking in terms of who's being protected from what. Not so 404, as we've all become very well aware. What does it stop? Private property use, development, profit, land use planning, all these things have been named. It resonates very differently, and like I said, it came from a different place. It grew out of the Army Corps' ability to protect actual navigation, and they got put into a much broader definition. So we have basically the same jurisdictional terms controlling both. If you want further proof that they resonate differently, I direct you to Justice Scalia's opinion in the Rapanos decision, which, after waxing excoriatingly against what the EPA and the Army Corps are doing under Section 404 in the style only Justice Scalia could do, he actually backs up and tries to protect Section 402 at the very moment he's contracting the waters of the United States definition. I can give you no better proof that they resonate very differently than what Justice Scalia was trying to do in that opinion. They also have been different timing legally, so this is just a rough and ready when has the Clean Water Act reached the Supreme Court. As you might expect for the complicated new regulatory program, a lot of decisions at the Supreme Court in the first decade, a lot of those directly NPDES decisions. And then kind of evened out if you look at the Act generally or NPDES in particular. But 404 bucks the trend, and the cases addressing 404 have actually been increasing, and a remarkably high number of those are jurisdictional in one sense or another, particularly with respect to WOTUS. And our first panel went through these decisions, so I'm not going to reiterate them in what they decided, except to emphasize that all of them came out of the Section 404 program. There is none of these decisions are addressing the scope of Section 402, and I actually would make an argument in Swank that the justices didn't even recognize they were simultaneously addressing 402 in the Swank decision. That had been clearly pointed out to them by the time of Rapanos, but not in Swank. All right, so Sackett versus EPA. Like I said, I didn't think I was going to be able to rely on yet another Supreme Court opinion for the argument. But once more into the breach, this is Priest Lake. It's a clearly navigable, in fact, commerce navigation, whatever traditional navigable waters definition you want to use, it's got it. Nobody's arguing about Priest Lake. What everybody's arguing about is this parcel of property that the Sacketts own. Has been mentioned. They are on their second trip to the Supreme Court about developing this property. It's now largely filled in, but I show this picture because it's not that far from the lake. All right, you would think it would be relatively easy to connect this to a navigable water of the United States. The Ninth Circuit actually unusually included photos as part of its opinion, showing some of those connections. They're taken from 2007 and 2008 because by the time of the Ninth Circuit decision in the second version of Sackett, the property was largely filled in. But I gotta love the Ninth Circuit. This is the actual logic the Ninth Circuit used to connect the Sackett's property. Now remember that photo, okay? The wetlands were adjacent to an unnamed stream 30 feet away and on the other side of road that's tributary to Kalispell Creek, which flows into Priest Lake, a traditionally navigable water. Those wetlands were part of one of the 5 largest complexes on a 62-mile long shoreline, and these wetlands in combination significantly affect the integrity of the water quality of Priest Lake. That's the Ninth Circuit's significant nexus analysis. I really wouldn't want to be defending that in the Supreme Court myself. And in fact, the United States brief relies heavily on the district court opinion, which much more simply said, yeah, the wetlands are directly connected to Priest Lake through a subsurface connection. All right, so that's what we're dealing with. Now, the cert question has been mentioned, whether the Ninth Circuit set forth the proper test for determining whether wetlands is, that's the Supreme Court, not me, waters of the United States under the Clean Water Act. What I think is significant about the way they phrase this is actually changed from the requested cert question, which is basically what opinion in Rapanos controls. And they switched it around at the Supreme Court to emphasize the wetlands. So I think a little bit more than which Rapanos opinion controls is going to be at issue in Sackett. We might be revisiting a footnote from Riverside Bayview that said we're only talking about directly adjacent wetlands. We leave all other wetlands up for further discussion. So I think that's on the table. And of course, we now have a new justice, so we've got the time I did this slide, she was not yet confirmed. That happened yesterday, all right? But we now have a new justice to add a little bit more uncertainty to the decision. So, WOTUS in the context, or in the wake of Sackett, or what I think Sackett's going to do, what can we do to leverage Maui County? To remind everybody, April 23rd, 2020, Maui County's decided that is an NPDES decision. In the NPDES context, the Supreme Court went out of its way to find jurisdiction. And it invented, and it was an invention, the functional equivalence test, that we hold that the statute requires a permit when there is a direct discharge from a point source into navigable waters, or when there is the functional equivalent of a direct discharge. In this case, going into an underground injection well through groundwater, roughly 83 days later, showing up off the coast of Maui on a very nice coral reef that shouldn't have treated sewage dumped on it. All right. So, what that opens up is a way of getting to a direct discharge that doesn't require immediate waters of the United States. And I think that is important for what the agencies could do. So this is just a rough outline, somewhat simplified, but I don't think distortingly so, of what the December 2021 proposed rule redefining waters of the United States does. We have the traditional navigable waters, and what I could call uncontested waters, waters no one has ever contested that can be regulated under a federal statute. The territorial sea, the ocean, waters that hit the Commerce Clause test, ebb and flow, the tide test, interstate waters. Everything else is basically using the either-or approach from Rapanos. If you meet either Justice Scalia's test or Justice Kennedy's test, you're in. Like I said, it's a little bit of a simplification, but not that much. And then two exemptions for waste treatment systems and prior converted copland. So that's the proposed rule as it's set up. Mostly goes back to the regulatory definitions that we had in the 1980s with what I call the Rapanos adjustment.
Robin, what is TMW?
Traditional navigable waters, sorry. Traditional navigable waters. The agency, EPA uses a different definition, but yeah, traditional navigable waters. Sorry, that was to keep the text boxes from getting way too small to read. All right, so what could you do with what I'm predicting Sackett will do, plus a Maui County definition? And I think you end up with an effect that's not all that different from what the proposed rule would do for 402, but maybe very different for 404. So you get the discharges into those traditional navigable waters. Again, ocean, territorial sea, things that trigger the commerce definition, the ebb and flow test, and interstate waters. Whoops. There we go. Plus, you get discharges directly into the adjacent waters. Riverside Bayview Homes is still 9-0, so the directly adjacent waters are probably going to stand up, although I predict that will be a direct surface water connection and not an underground connection after Sackett. And then with Maui County, you get the functionally equivalent discharges, which, like I said, is going to, in my humble opinion, anything that can pass the significant nexus analysis under 402 is probably going to be able to pass the functional equivalent discharge analysis. Maybe some timing, maybe some distance constraints, but that's going to be mostly the same category. I think it's going to be very different for section 404, and so I think that's going to be the prong that could distinguish those two permit programs in a way that could be significant. But I think, like I said, if Sackett does what I think Sackett is going to do, the agencies could promulgate this sort of regulation, be perfectly in concert with the Supreme Court decisions that are out there, and very successfully have a much broader 402 program than a 404 permit program. Whether that's good, bad, or indifferent, I leave to discussion. Like I said, this is a reaction to the fact that Section 404 has been driving the scope of Section 402, and I'm attempting to say, hey, if you wanted to reverse it, could we do it? I think now we can. So I'll just leave you with the thought. In other words, if what I suggest actually comes to pass, we'll care less about what water the pollutants are going into and much, much more about where they actually end up. And so with that, thank you very much.
Okay, great. So I'm going to take a bit of a detour from waters of the U.S. here and talk about the total maximum daily load program. So let me just start with a bit of context here. So I just pulled this off of the EPA website a couple of days ago. And just, you know, there's, I think, a few interesting things about this particular look at the overall health of waters in the U.S. First of all, we're still only assessing about a third, give or take, of the water qualities throughout the U.S. This is not a new number, but interesting to see that 50 years on, or maybe 20 years on since TMDLs and the associated programs were actually starting to be implemented, we still have huge gaps in the data we have about the waters of the U.S. The second piece is there's a lot of impaired waters, right? So the red numbers are quite high. As I was actually pulling this out, I was quite surprised by how different the numbers of impaired waters are across different types of water. So rivers and streams versus lakes, very different percentage of waters that are being found impaired. So a few different reasons for that. That is not what I want to talk about today, but I think important to know that the number of waters that we have in the U.S. that are listed as impaired is very high. And so for these waters, we are developing total maximum daily loads, as you all are familiar with. So this number is up to around 74,000 right now, approved total maximum daily loads throughout the U.S. Note that this number doesn't really go down because once a TMDL is issued, it for the most part stays in place, which is in fact EPA's advice to ensure that the water quality for these bodies is maintained over time. So with this large number of total maximum daily loads, which are intended to improve the health of these impaired waters, the big question is whether or not total maximum daily loads actually work. So looking at the evidence that's out there for this particular question, there's been existing studies, but they tend to focus on how far along the TMDL program is in its implementation process. And so a lot of EPA's work and kind of general congressional reports answer this question of TMDL implementation status. Suffice it to say, there's a lot of gaps in that implementation process, but that's not what I wanted to focus on here. I want to actually think about what impacts we're seeing on water quality after TMDLs are implemented. So there's also been a number of more individual studies that look at, in specific water bodies, how implementation is being done well and in what cases we start to see improvements in water quality over time. The larger question of whether or not we're seeing TMDLs improving water quality across the US after implementation is largely unanswered at this point, and so that's what I'm trying to tackle with this particular study. Suffice it to say, it's a very big question, and so I've kind of chunked this into a couple of different parts, and what I'm reporting on today is what we'll call chunk one, which is some initial data, but there are several chunks to come, so I'm happy to talk about each of these different pieces. Also worth noting that I've simplified this data a good bit, so if you have methodological questions or more in-depth questions about the data side of it, I'm happy to dive into them, but I didn't want to make this too technical for today. So one of the questions that I'm looking at here is basically, there's a very easy indicator of whether water quality is improving over time, which is looking at whether its status changes from being impaired and listed on the impaired list to moving off of the impaired list and being listed as good, right? And so this is relatively easy to track with the EPA's water data portals, which incidentally have gotten much better in recent years. So great to see the efforts that EPA is making to improve that type of mechanism. Okay, so these are waters that are moved off of the impaired list over time. It's a significant number if you look at it, several thousand a year usually getting moved off of the impaired list, and there's not really any trend associated with this over time. What I did is looked at the reasons for these delistings. So why are waters being moved off of the impaired list? And you'll see the vast majority of the time it's because there's been a TMDL approved and put into place. And so In some cases this happens, in some cases it doesn't when there's a TMDL approved, so this makes the data analysis a little bit odd. But this is a big reason. Another big reason is that there's a change in terminology in terms of how standards are being developed and what baselines are, or if there's resegmentation of the particular waters. There's a very small percentage, so 1%, where we're seeing water quality standards that are being attained for one reason or another. So about 1% of our waters that are no longer on the impaired list, it's because there was some notable improvement in their water quality over time. But I was really interested in this segment where we have TMDLs being approved, but we don't really know if that means that their water quality is getting any better or not. So what is happening in this particular category of waters? So in this category, do waters that have been taken off of our 303D lists but still have TMDLs in place, do we see improved water quality over time in those particular waters? And so what to think back, right, there's about, this is about 35-65 breakdown, where 65% of the TMDLs are remaining on the impaired list. So those ones we pretty much know that they're remaining impaired, right? They're still on the impaired list. There's a good reason to suspect that they're still impaired. 35% are removed from the impaired list, and these ones there's a question about, right? There's a question whether or not their water quality has actually improved, even though they're not on the 303D list anymore. And so after doing a pretty intensive random sampling of this group, so this is 74,000 TMDLs, right? So there's about 24,000 in this list that have been removed from the impaired list. So obviously I can't look through all of those in a lot of depth, even with an army of RAs. So we did a random sample here that at this point is pretty extensive, but working to make that sample larger as well going in the future. And found that in about 1% of the cases, we see improvement in the waters over time. So this is not a super optimistic picture of what is happening with the total maximum daily load program, I'm afraid, and I wish it were more optimistic because it's the kind of thing that doesn't necessarily strengthen the case for why the Clean Water Act is important. But I think this is a very important data point as we analyze where to go, particularly when it comes to non-point source pollution, which is such an important factor in determining nationwide water quality. So here, right, we're seeing that in about 1% of cases, the total maximum daily load program, we've seen waters that have TMDLs improve in water quality. And so these ones actually, we're looking both at whether or not their status has changed from impaired to good, but also on a more granular level, whether we're seeing actual numerical improvements in water quality within those rivers. So some evidence that it's working in some cases, but the vast majority of cases, there's not a significant improvement in water quality in these bodies as a result of the TMDL program. So a couple of takeaways from this, right? Mostly these TMDLs have not led to significant changes. There's still a lot of data gaps in these particular studies, looking at whether or not certain types of data is available has a large impact on the quality of these results and the robustness. So I think for this project, there's a few next steps and places that I plan to go with this quantitative research. And the first is looking at not just with these TMDLs that have been taken off the impaired list, but with a broader category of TMDLs, looking at more in-depth information about those waters and looking at whether or not there's been an actual change in the underlying water quality, as opposed to using this impaired, not impaired as a proxy, because there's some problems with that. Unfortunately, this step is much more time intensive and requires significant resources to look through each TMDL in depth and understand why they're being listed, what the deficiencies are in their current status, and then what their current water quality is. With some states, it's much easier to find that information than with others. And then there's a lot of heterogeneity by states, both in the number of TMDLs enacted, but also in how these TMDLs are being implemented. So this, of course, has a big impact on what states we're seeing more success with TMDLs versus less. And so next steps for this project are certainly to look more at that heterogeneity and understand better where and why TMDLs may be implemented more successfully. And the last is there's a few areas where I've begun to identify essentially paired TMDL and non-TMDL waters to try and come up with a way of getting to a statistical understanding of not just in the same water body whether there's water quality improvement over time, but if you can see if there's a TMDL on one water and a not a TMDL on a very similar water, whether or not you can control for all the necessary factors to really understand whether or not that TMDL has led to any significant improvement. Because it's not just the TMDL that's at a rate, but also the surrounding water quality. So if there's stressors, it may be that the TMDL is working better than having nothing, but it's hard to say that without these controls. So that's another piece, but that's one that's much more resource intensive as well, so longer quantitative projects to look at. But I think this initial data gives us a good understanding of, at least at a broad scale, how effective the total maximum daily load program has been. It's been roughly 25 years since it's been kind of meaningfully implemented around the US, so a significant amount of time and a good place to take stock of how successful this program has been. I don't think this result is particularly surprising. If you look at the studies that have been done and the literature by other academics, there's a broad understanding that the TMDL program has fatal flaws in the fact that it doesn't have as many teeth as we would like to see. But I hope that this work helps to highlight perhaps the extent of the issues with this program. And my goal here was not to point to solutions. There have been many, many papers, many by people in this room about how to potentially target non-point source pollution in a more productive and efficient way. The TMDL program right now is perhaps not doing that. It's also very costly, right? It's hard to get exact numbers from EPA on how costly it is, but it's certainly in the billions of dollars according to estimates. So something that requires significant resources, and we're not necessarily seeing the changes on the ground that we might want to see as a result of that.
Thank you for joining us by Zoom. I'm sorry that you were not able to join us in person, but
Me too.
yeah.
Yeah, so it's a pleasure to be here. Really interesting presentations by the first two panelists, so I'm excited to engage in some discussion afterward. So I'm the first non-lawyer on the panel, so you'll forgive me for focusing on benefits and costs, like economists do. But I think one of the things that's an interesting connection to some of the prior talks is that you'll see that some of the kind of economic downsides of the CWA are related to jurisdictional questions too, not so much over which waters are covered, but over kind of which sources of pollution can actually be regulated. And this also links to some of the comments that Professor Brett just offered. So should I share my screen, or are you? Does that make sense? Or is someone going to click through my?
Sure.
I can do it either way. Okay, so let me share. Can you guys see my slides?
Yes.
Can you both see them? Yep. Okay, great. All right, so the problem I'm going to focus on today is the problem of nutrient pollution, because I think it's kind of a classic example of a case in which the Act is maybe not kind of perfectly designed to address an important pollution problem in terms of thinking about where the actual causes are and what the costs of, and benefits of, might be of addressing it. And so that is the problem of nutrient over-enrichment. So again, forgive me if folks in the room already are quite familiar with this, but the idea is that nutrients like nitrogen and phosphorus run off of land, it could be agricultural land or urban land. Sometimes they make their way into waters from atmospheric deposition. That's an important cause in some places. And when that happens, those nutrients create good conditions for plant growth, but if it's too much, you get an overgrowth of algae. As they die and decay, they use up oxygen, sinking to the bottom, and then you end up with areas that are hypoxic, areas where aquatic organisms can no longer live. Some of those organisms can move out of the affected areas, and others can't, and so you end up in some cases with dead zones, which are really prevalent around the world, but also here in the US, we have a lot of challenges with this particular pollution problem. Places, that you might spend time, the Great Lakes are not coastal in this map, but the Great Lakes certainly, have challenges with eutrophication and hypoxic areas, as do much of the kind of US Atlantic and Gulf Coast and increasingly the Pacific Coast as well. So there are some challenges to addressing this important pollution problem. The first is that I think economic analysis is just beginning to monetize the damages from this type of pollution. The second is that agriculture, which is often but not always the primary source, is only partially regulated under the Clean Water Act. The third is that sources of nutrients that create these damages are often far upstream and very often out of state, of the most direct damages. And then finally, the kind of regulatory temptation in this setting is to, right, when everything looks like a hammer, or when all you have is a hammer, right, everything looks like a nail, right, toward more stringent controls on point sources, which are both costly and potentially questionably effective when we look at kind of where the problem is coming from. So I'll show just a little bit of data on both of those points. So to the first challenge, I think, because historically, sort of nutrient pollution has been emerging over time as a really important pollution problem. There's good understanding of impacts on commercial fisheries, especially in the Gulf of Mexico. There is emerging evidence of health effects from harmful algal blooms, which are related to nutrient over-enrichment. For example, there's a nice paper by Ben Jones at the University of New Mexico showing a causal effect of harmful algal blooms in Gould, Michigan on low birth weight. So those health effects can have quite large economic consequences once you start to see those, similar to what we see on the air pollution side, but of course the scale is much larger, for damages on that side. And then there are also occasionally water utility closures, like the city of Toledo sort of famously, had to close its, prevent people not only from, drinking water, but you can't even boil it, right, once these organisms are in the water. It's very dangerous to human health. And there are costs associated with those kinds of impacts as well. But to my knowledge, not quantified, not well quantified. There are also recreational damages, and those are beginning to be quantified, and I'm going to focus on that for just a minute. And then also other property value impacts of these increasing kind of areas of nutrient over-enrichment. And then there also is new evidence of climate damages from this, because eutrophied lakes emit methane. Methane is a potent greenhouse gas, and so there is this kind of climate water pollution link that I'm interested to talk about in the discussion as well. So just as an example of the kind of pollution I'm talking about, in Tampa, Florida, where I've just completed a study with several colleagues, you can sort of see these, algal blooms and, sort of the effects of nutrient over-enrichment from satellite photos, looking at that kind of greenish fringe around, where the nutrients are running off the land. You can also see it as, macroalgae mats, at the top of the water. This happens in the Great Lakes, happens in coastal areas in the United States when blooms are significant. And then sometimes, as the tide goes out, you can leave these mats kind of stranded on sandbars and areas, close to cities. Tampa had significant challenges with this through the 1970s, 1980s, and into the 1990s. So when we think about valuing the damages from this kind of pollution from the economic perspective, one of the things that has been a real challenge is moving over a lot of the damage estimation techniques that have been used for air pollution into the water pollution case. And one of the ways in which I think we've gotten this wrong in the many past decade or so has been to really just kind of import those methods. And just as in a very broad sense, one important tool that we have is looking at the impacts of pollution on property values using what's called a hedonic property approach. And just as a basic idea of this, you sort of look at people's residences, and you kind of draw a circle of varying radii around those residences, and you measure concentrations of pollutants within those radii. And you look at changes in pollution due to something like, being, in non-attainment with the Clean Air Act. And then you use statistical analyses to estimate the impacts of those pollution changes on property values. And again, the focus is very much on your exposure kind of in or near your home. And in the water pollution context, some new work that I've done with colleagues suggests that that's maybe not the best approach when we think about water pollution. That people don't necessarily sort of experience water pollution very close to their home, and in fact the data bear that out when we look at studies that have been done on kind of water pollution impacts on property values. Those tend to go to zero very close to people's residences, so within, say, 2 to 3 kilometers of people's homes. So just to kind of give you some intuitive sense for why I think this has not been right, this is a map of the city of Boston, so where sadly I am today instead of up there in Cleveland. This is my house, marked right here, 3204 Kirby Lane. And so I'm an aquatic recreator. I kayak and I swim outside, and I try to do those things at least 2-3 times a week. And if I just showed you this map, and I asked you to guess where it is that I spend most of my time in water, it would be hard for you to figure that out, right? Not knowing my preferences or patterns of my own behavior. Really close to my house, there's this Shoal Creek, which is an ephemeral stream, like most streams in Austin, a semi-arid region. And I care about water quality in Shoal Creek. You know, I walk there with my dog and my kids. We step on the rocks. We don't get in the water. I care about it. If it smelled bad, you know, that would bother me. If it looked bad, it would bother me. But mostly, I care about where I spend time in the water and on the water. And my two spots are here. So there's my house. Here's Sculpture Falls, which is on Barton Creek, which is also that's an intermittent surface water flow there. And then there's Barton Springs, which is a sort of famous Austin institution, 68 degrees year round. It's a little chilly, but when it's 105 outside, it feels really good. It's right downtown, it's an eighth of a mile long, and wonderful water quality for most of the year. So I care very much, right, about water quality in these places. And if you were to draw a circle around my house, even if you drew a really big circle, and you said, hey, right, these are the places that Sheila might care about and value, you probably wouldn't capture those. And even if you did, you would also capture a whole bunch of other places where I never go, I have no idea what the water quality is, and I probably don't value the change in that water quality very much. So we take a different approach in some recent work, and we say, hey, let's actually look at people's patterns of recreation and see, kind of how that influences these estimates we might get of the value of water quality improvements from this property value approach. And we show basically that these estimated property value impacts are mostly recreational. Again, that's not necessarily true in all places. This is for Tampa, Florida, where there are a lot of kind of large, charismatic water bodies, lots of recreational activity in and on the water. But at least in this case, you really need to know where people go, right, in order to get this right, in order for those estimates to kind of to be even close to, to what we think their true value might be. And so in this particular case, the benefit from just from increased property values of cleaning up Tampa Bay, which is something that the city accomplished over a many decade period, likely exceed the cost. And that's not something that we see very often in benefit cost analyses of ambient water quality policies. The other thing I would mention is that, again, this recent work kind of with the climate change link, that methane emissions from eutrophic lakes worldwide have a climate impact that's about 20% of that from fossil fuel combustion and production. For Lake Erie, this is the case that we examined in this paper. The climate change damages from methane emissions may exceed all of the previously monetized recreational damages from eutrophication. So our sense from this case study is that those damages in the US context could be quite significant, right? That doesn't mean maybe we've just done a poor job estimating the recreational damages, right, from fishing and beach closures and so on. But in any case, the climate piece is potentially quite important here when we think about monetizing damages. So the second challenge that I mentioned is that agriculture is often the primary source of this kind of nutrient runoff into water bodies that creates these damages. And I'm just showing you a couple of pictures here on the left-hand side. This is just looking at nitrogen, the nitrogen inventory in the United States, going back to 2012, but it's a 2019 paper, right? So some of this kind of inventory data is not collected very often. And what you can see is that these are the contributors over here, right, to the inventory of nitrogen in the United States. And ag fertilizer, biological nitrogen fixation by crops and livestock waste together, those three contributors are the lion's share of the contribution of nitrogen, one of these important nutrients. And almost equally as important, if you look at the bottom of the list, things like treated and untreated human waste, urban fertilizer, are very, very small contributors. Now that's not true everywhere, and it depends where you're talking about nitrogen or phosphorus, right, in which basin, which watershed. Just on the right, this is the study of the Great Lakes, and what you can see for Lake Erie is that agriculture is a big part of the story for total phosphorus. This is something that's well known and is playing a large part in public conversations about what can be done about eutrophication in Lake Erie, but maybe less so for nitrogen on the bottom, right? And again, that you can see that those contributions from different sectors vary a lot over space. So how do we think about that? Another big challenge is that the sources of nutrients are often far upstream of the ultimate location of damages. And that's not to say that the runoff of these nutrients into local waters doesn't create local damages. It does. But one of the bigger concerns one might have, especially when you think about federalism and the nature of the Clean Water Act and where it might have come from, this kind of concern about cross-border pollution problems and so on. This is on the left, a picture of just the geographic extent of the dead zone in the Gulf of Mexico from summer 2021, and on the right is a map right from the U.S. Geological Survey showing the states that make the kind of primary contributions of nitrogen and phosphorus, that contribute to that problem every summer, right? The sort of growing concern about hypoxia and dead zones impacts on commercial fisheries and other outcomes. So what you can see is that, right, the states that are immediately neighboring the Gulf of Mexico really are not big contributors, right? The big contributors are kind of in the upper Midwest. This is something that's widely understood from a scientific perspective. And again, it creates a real challenge for regulation. And then the fourth and final challenge is that, regulation as it's currently set up under the Clean Water Act really can't harvest the low-hanging fruit, right? The low-hanging fruit are these agricultural sources in many cases, right, that have not been adequately addressed. And so if we don't focus on those, then the effectiveness of regulation altogether is impaired. So if you have that kind of nitrogen mapping in your mind and you think about where the big flows are coming from, and we say, well, we're just really going to hammer on urban stormwater, right, or kind of urban fertilizer use, which is not uncommon in some of the TMDLs that Professor Brett was talking about a moment ago. What you understand is that that's a really tiny slice of problem in many places, right, where the kind of agricultural contribution is so large. So even if you entice farms into the system through water quality trading or other means, right, with a really tiny slice of the problem, actually engaging in the reductions is really very hard to affect the problem. So economists, again, this is something widely known for a long time. Economists at the USDA showed back in 2008 that among watersheds that are nitrogen impaired in the US, point sources contribute less than 10% of nitrogen load in 2/3 of those watersheds. Another thing that happens when we kind of can't access those low-hanging fruit in agriculture is that the costs are really quite excessive. So just to give you one example, you don't need to read anything on this graph except the scale of the vertical axis, right? So on the left, this is taken from a study of the potential for nutrient credit trading in the Chesapeake Bay watershed, which is governed by a TMDL that combines 92 different smaller TMDLs. And on the left, what you can see is the cost of several common agricultural best management practices, right? Changes in land management practices that could reduce the flow of nutrients and other pollutants into the bay. And on the right, what you see is a set of urban stormwater best management practices, which are in urban settings a similar way of reducing flows. And this is just for phosphorus for the Chesapeake Bay. And what you can see in the scale of the vertical axis on the left is that those agricultural best management practices are really cheap relative, right, to the scale of the vertical axis on the right side, where on a kind of pound per pound basis, the costs of controlling these pollutants in an urban setting are an order of magnitude or larger, than the cost in agricultural settings. So just to sum up, as a primary cause of impairment in U.S. rivers and streams, nutrient pollution causes really significant economic damages. The focus on already heavily regulated point sources is both costly and may be marginally effective in some places. The TMDL process does reveal the extent of agricultural contributions. So that is to say that there may be some benefit of going through this kind of holistic budgeting process of the TMDL and saying, right, we think this much of the contribution is coming from agriculture, this much from urban and other sectors, right, industrial sources and so on. But, right, how much does it reduce nutrient loading from crops and from livestock, right? This is similar to the question that Professor Brett posed earlier, but a little bit more narrow, a little more specific. And then finally, I would say, right, states do work on this as well. And in some of the even predominantly agricultural states, there's increasing attention to the local damages from nutrient pollution. And so many states have adopted, with encouragement from EPA, numeric nutrient criteria. So I think there are really interesting questions to talk about in the discussion about whether these state-based approaches can do any better. Because of that map, right, where we sort of can understand that for many of these the hypoxia problems, the sources are way upstream of the ultimate destination of those nutrients, right? The sort of state-based approach is never going to solve, right, that problem. But right, there might be progress, right, based on kind of damages, local damages within state borders. So that's all I have for now.
I want to thank all the panelists for some really thought-provoking presentations. I think they've all raised some very interesting questions about, can a 50-year-old statute confront the challenges that we're facing today with water quality given changes in land use and practices? And so I'm sure there are going to be a lot of questions. I see some hands already. Let's start. Fair?
First of all, just thanks for the presentations. I learned something from each of them. That was great. So Annie, of the 1%, I realize there's a lot of heterogeneity within the states. I mean, I have sort of my hunch of which states you'd see more success with the TMDL. So I'm curious, have you had a chance to look at the data in which states seem to be able to take the those water bodies off the list successfully?
Yeah, so I haven't done a full analysis of this yet, so I don't weigh too much into what I say, but it actually has been surprising. It hasn't been the usual suspects in the sense of what I would think. It reflected in where the TMDLs are being most effective, which suggests that it's maybe not something about how the program is being implemented as much as it's some characteristic of the water bodies in that state, or at least that's my initial thought on the matter. But that there's much more to do on that front, and I think that, some places there is, some of them are not surprising. I think the states where there are relatively positive progress, but there's many where you wouldn't necessarily expect it based on what their state reputation for environmental protection is. So I think there's more to unpack there than just a simple look at state EPA action.
So also a question for Annie. First off, I think it's really cool that you're doing this study. It's something like this I had thought about doing in the past, and then I thought about the data needs, and I got scared and I ran away. And I'm wondering if you are, this may be too early, but I'm wondering if you were seeing differences for TMDLs for water bodies that are heavily influenced by point sources, where there's more of a mechanism for turning the TMDL into real controls.
Yeah, that's a great question. So I actually read your paper that was calling for something similar to this after I started the study, and it was a great confirmation that this was something useful to put out into the world. So thank you for that. And understandably, being scared off is I'm surprised I haven't been yet based on how it's been working with this data. But that isn't something I've actually factored for yet, but I think it would be a really interesting addition to the further, more in-depth look that's coming in the second piece of this study. So I agree that anecdotally, early on, there's been a difference between, it seems like, waters that are more remote versus ones that are in more urban or concentrated areas. So I would expect that point sources may be a part of that distinction, but that's certainly something that in the further, more specific parts of the study I'll look at.
Look at that technique. So first, thank you for great presentations, all three of you. But I guess this question is mostly, or a two-part question, partly for Annie, partly for Sheila. So first on Annie, looking at your data, have you had any sense about increased intensity of uses? In other words, TMD results can be static, yet still reflect effective use. And the only reason I asked that is I was involved in some early TMDL litigation in the Southeast, and that was what was going on. There was more intensive agricultural and urban growth, both, and so there was this. So basically, there were redoubled efforts, but as far as showing improvement, not necessarily, but yet it was improving results because of redoubled effort. So that's just a question for you. And then the question for Sheila is, you had that one slide where you said something like you can't, or that the law doesn't allow. And I guess my sense is that when you look at the TMDL and water quality relationships in the Clean Water Act and a case called Michigan versus EPA, which basically creates a default rule allowing for cost-effective regulation, Supreme Court case called Homer, which allows for cost-effective cross-border pollution trading, and then the general federalism provisions within the Clean Water Act, that actually people within the TMDL process, states and sources, and also I should say the Chesapeake TMDL itself, which is approved by the Court of Appeals, there is this ability to effectively for states and or sources to go upstream and find cost-effective trading strategies that would achieve results. And so I guess I wasn't sure if you were saying you can't or it doesn't directly mandate it, but I think there's I'd be very surprised if any court would these days find that to be a prohibited strategy to achieve results?
Yeah, so I'll answer quickly and then let Sheila jump into that second part. So this very question is, I think it's true nationally, is where we see great increase in use that causes increased pollution. So looking at whether TMDLs are effective over time, you can't just be looking at whether the water quality in those bodies is improving over time, which is why I'm really interested in this idea of essentially comparing water bodies where TMDLs are in place and where they're not. And if you can get ones that are geographically similar, there can be some, and I'm working with some colleagues who are more statistically savvy than I am, and water quality savvy as well on this piece of it. But because there are so many waters that are impaired but don't have TMDLs in place, there's actually a number of examples where you can see impaired waters versus impaired waters that have TMDLs and see if there are significant changes. So that's the way I'm trying to address that question, but I think it is a big one.
Yeah, thank you so much for the question. So the first thing I would say is that, yes, it's true that in the Chesapeake Bay, TMDL, and others, you see, right, these water quality trading programs where even though there's no cap, if you think about it in kind of policy instrument choice terms, right, on the agricultural sources, the realization that that's where the low-hanging fruit is encourages, right, policymakers to design the TMDL approach so that, you know, if I've got, you know, caps on urban stormwater and on industrial point sources and on municipal, you know, waste treatment and so on, wastewater treatment, then, you know, that you can set up systems where, right, those, you know, the kind of regulated entities can sort of purchase, right, agricultural BMPs, you know, upstream and so on. I think the biggest challenge to that, though, is that where you have you know, a large majority, right, of phosphorus and nitrogen coming from agricultural sources, if the cap is only, right, the kind of official regulation is only covering, you know, let's just pick a number, 10%, right, sort of 10% that's coming from urban stormwater and municipal wastewater treatment and other point sources, where, you know, you can have an EDS, you know, the tool, right, they can only go down to zero, right? If you go down to zero, you're still not solving the problem, right? So even if they're purchasing, right, their kind of required reductions from others, right, leaving all that, right, that fruit on the tree is not going to solve the problem. So there may be places, right, where that water quality treating can reduce the costs of, you know, and that was the point of that study by George von Hoffen and his colleagues that I showed those estimates from, where you can, you know, take a significant chunk out of the problem, you know, just by engaging, right, in water quality treating. But with where those sources that, right, that are, you know, kind of under NVDS permitting only contribute a small part of the problem, right? It's going to be very minimal, right? What you can actually achieve. And then the last thing I would say is that, you know, I think Professor Brett's study about TMDL effectiveness, it kind of couldn't be more important, right? If this is the way, right, to sort of, you know, reduce impairment and move forward, I think understanding how effective it's been is really critical. What I would point out, though, is that there are important, you know, reasons why you might see that really small sliver, you know, that 1%, one of which, right, and both of these have to do with what I call endogeneity, right, or concerns about kind of underlying heterogeneity and confounders. The first is that, you know, it could be very, very small because maybe places where, right, you know, you anticipate future increases in pollution are also likely to be listed, right, and also likely to have a TMDL put in place. And so what you're seeing is, you know, you've got this increase, right, the TMDL is put in place, maybe it continues to increase, but maybe increases at a less steep rate. So I would be kind of holistic in thinking about what those impacts are, right, and how you might control for these kind of confounding factors. You could also tell the opposite story. Maybe the sliver is too small because, you know, places where, you know, you mentioned kind of places that aren't super dense, right, and places where there's not a lot of competing development, are places where you might see improvement. Well, it could also be that it's politically feasible to kind of complete and implement, right, and enforce the TMDL where the costs are fairly low, right, and where we don't see, right, that, you know, kind of that future trend of increasing pollution as much, right, there's just not as much competing. So there, maybe the 1% is even too small, right, because you'd be attributing these pollution reductions to the TMDL, but really it's, you know, simply because of the nature of the place. So you hinted at that, Professor Brecht, when you talked about, you know, thinking, well, maybe this is something about the nature of the places, you know, more so than the TMDL itself. And I think that's a really important hint, right, that your kind of gut feel that you have. And statistically, I would say that's definitely something that one would want to worry about. But I think it's a super important study, and would love to talk more about how you can handle some of those challenges.
My question is also for Professor Brett, but I first want to give a shout out to Professor Craig about those awesome graphics with the webs. That was fantastic. The question I have is more the word water quality, and I'm not trying to be a textualizer, which is a word I learned today, but it's an elusive definition, and I wonder how it is defined and whether, how is it being measured? What does an improved water quality mean? I mean, because it's just such a broad term in many ways, can be subject to interpretation, and that's something we struggle with sometimes too, so.
Yeah, that's a great question. It's obviously one that the states also struggle with in determining what their ideal uses and water quality standards are for these water bodies. So I've really been looking at letting the states essentially determine what the water quality goals are for each of these water bodies and then measuring based on those state determined goals, right? So each state has its definitions of what designated uses are and what water quality standards are for those, and EPA obviously provides guidance on all of that. But yeah, I've been really deferring to the states to answer that specific question because it is a loaded one, and certainly many different legal interpretations of what that could mean. But I've been very much basing my analysis on those water quality standards that states are using.
So I'd like to step in for a second and step back and ask all the panelists a question, because I think what we're sort of skirting around here is a similar question I think about a lot with the Clean Air Act, which is we have a very old statute. We have some very new problems. Non-point source pollution is newer than point source pollution. Climate change is newer than NOx and SOx regulation. And when you think about, is the Clean Air Act, is the Clean Water Act up to the task of solving the problems that we're facing today? And if you don't think it is, should we be looking at other approaches? And because we have an economist here who can address it, should we really be focusing also on using markets more than we maybe have talked about? And or do you think the regulations are going to serve us well? So I'm gonna.
Well, I'll jump in. Some of these are not new problems. Non-point source pollution in particular, Congress knew exactly that it existed at the time it wrote the Clean Water Act, and it wrote the Clean Water Act in a way to leave most of that to the states, on the recognition that a lot of non-point source pollution involves land use decisions and regulating actual use of land, among other things. So, like I said, that was a conscious political decision, conscious, what we want Congress to be doing, deciding what to go after first and what to leave to later or to other regulatory bodies. I think the real question is, 50 years down the line, when we've plucked the other low-hanging fruit that the point sources gave us, and we're dealing with interlinks between the statutes. So I deal a lot with ocean acidification. You can't deal with ocean acidification through the Clean Water Act. The sources are wrong. You just can't get there. And so, do we need to rethink those initial decisions 50 years ago for new realities? Like, okay, we took care of the first cut. Now, do we think about, and nutrient pollution often comes from air sources as well, so do we need that link? Do we need to think about, well, we definitely need to think about how climate change fits into all of this. But like I said, it's more of a, we need to reboot, and we haven't had a real rethink from the ground up of these statutes in a long time.
I don't know if Sheila wants to jump in on the market mechanism side. I don't have too much to say about that as not the economist here, but I agree with what Robin has to say. I think certainly on the non-point source pollution side, the Clean Water Act has not been up to the task, and that's a recognition. But maybe, as Professor Olmstead did point out, there is value in going through the process of certainly monitoring these waters and then doing in-depth analyses of where nutrient loading is coming from. That provides a solid foundation for something to happen. It's just not happening yet. So there are ways in which I think there are important pieces of what we're doing now, even though it's not ultimately maybe leading to the change that we want to see on the ground. There are pieces that are very important foundations of whatever might come next, which I'm not entirely sure what that should be.
Yeah, I would say I agree wholeheartedly with Professor Craig and Professor Brett on these points, and that, you know, a reboot would be really smart. I think I mentioned in a podcast earlier this year on the WOTUS question, but you could sort of, like, the Congress could address a lot of these issues if it clarified its language with respect to waters of the United States, if it considered what the sources of pollution are, you know, for important problems that people care about, and tried to match those a little bit better with what, you know, it's possible to regulate, and whether some of these linkages between the Clean Air Act and the Clean Water Act ought to be, you know, kind of more explicitly stated. I think on the market side, I have a couple of comments. The first is that, you know, and this is, I'm going to state this, but I don't necessarily think that it was a good thing, so I'll state it. That, I mean, I think one of the things that Professor Busby talked about in the earlier panel is that, you know, the CWA is a kind of muscular, right? When you read the text of it, is a kind of muscular from a scientific perspective of kind of what it is that it's trying to achieve. But it's also pretty muscular from an economic perspective, right? It says we're going to go to zero emissions by 1986, right? Clearly that didn't happen, right? And that's not where we are. But when you know, even the Clean Air Act, where we say, you know, we shouldn't be considering costs when we you know, set the NACs and those kinds of things, there are still like kind of places in the Clean Air Act where you have a sense that, you know, that costs can matter for, you know, in certain deliberations. I feel like the Clean Water Act is less friendly, right, to kind of consideration of costs. Maybe that's, you know, that's just my kind of high level impression, and again, I'm not a lawyer. But it strikes me that the starting point, right, is pretty strong, right? The sort of statement that was made in the 70s is pretty strong, and the question is whether if you went through, you know, by a process in the Congress today, whether you would get something equally strong. And I think the answer is no. So I think we would worry, and I you know, one question I would have, you know, is, you know, if we're concerned about these pollution problems, you know, whether that would be a productive process or not, right, at this point in time. The other thing I would say is that the focus on using markets, I mean, you know, I think EPA has tried to encourage this for years, maybe decades, right? This realization that, you know, there are the kind of lower cost approaches and in some particular pollution problems, and, you know, kind of continuing to ratchet up, you know, standards for point sources is not a new one. You know, the weaknesses, I mean, and obviously, right, as an economist, I think markets are great. They can do many things. I think there's a couple of challenges in the water context. The biggest one is this problem of, you still, right, if you're only capping the sources that are, you know, explicitly regulated within NPDES permits, and they don't contribute anymore a lot of the pollution, right, in some places, you can't through markets, right? That's the amount you're going to get, right? Is that small amount that's coming from those sources, even if they're paying, right, for reductions elsewhere. You're not going to be able to sort of charge them for pollution below their, right, you know, their baseline of zero, right? That there's just only so much you can do through markets at this point for some of these pollution problems. The other thing that I would note is where markets have been used and used well, you know, the challenge of non-uniform mixing, the challenge of having to set up like effective systems of trading ratios is just a more significant challenge than it's been in the air quality context. You know, talking about something like carbon, that's really easy, it doesn't matter, right, where it comes from. SO2, NOx, we could be worried more than we have been about those, and there are good studies suggesting that, right? There could be big improvements in kind of the welfare gains from trading if we worried about, you know, the particular damages at individual locations. But in the water context, we really can't get away from that. And it is complicated, and when you look at these water quality trading systems that seem to be working well, you know, they've addressed those questions, and those are kind of scientific, economic, and political questions, right, all kind of folded into one, and they have to be made at the, you know, at the time that the thing is set up, and then they have to be flexible in response to scientific information that comes in across the, you know, the bow later on. And that kind of iteration, you know, considered scientific deliberative process is just not one, you know, that happens that often in the context of pollution control, because, right, it is so charged and it has so much to do with these kind of land use constraints and other things that happen in the locations where these systems are implemented. So that's my thoughts.
Great, thank you. And one last comment? Sure. And on that complexity, I mean, water's just a different animal than air, and so I did a lot of work in the Pacific Northwest. There are a lot of streams and rivers in the Pacific Northwest that are on the Impaired Waters list. They're on the Impaired Waters list because of designated use of salmon, and until the big hydropower dams come out, they're never going to be in compliance with the Clean Water Act. And so when you're dealing with that kind of holistic picture of what's going on with the water body, again, what a single statute that was really thinking about industrial sources piping pollutants into the waters can do about it needs a redesign.
Okay, I think we had some.
I had a question for Robin.
My question is for Robin. Robin, you were so disciplined with your time that I think you didn't have a chance to do what I want to ask you to do, which is to take your proposal about the questions you raised about distinguishing WOTUS between Section 402 and 404 and react to the first panel, especially maybe the study that Brother Adler gave us about vocabulary. And I just wonder how what we heard in that first panel impacts or changes your thinking, if it does at all, about your proposal.
It actually confirmed a lot of what I was thinking, which particularly the acontextual approaches to waters of the United States. And one thing the debates over the 2015 and the 2020 rules brought out was you were hearing, I'm going to pick on the Farm Bureau because a lot of the arguments came from the Farm Bureau, but you were hearing arguments that this one definition of waters of the United States, which is one part of a 5-element test for Clean Water Act jurisdiction, was suddenly going to subject huge areas of land to regulation. And I thought it was particularly ironic coming from farmers, because it's like, yes, but you're never going to be a point source, and you're never going to be this, that, and the other thing, and your return flows are specifically exempted somewhere else in the Act. And then you've got all the 404 exemptions. And it was that decontextualization of what that definition was doing that drove a lot of the controversy that was largely unnecessary. And so when I started this project thinking it was going to be mostly an administrative law project riffing off of County of Maui, I was thinking in terms of, hey, stop defining waters of the United States in isolation, back it up and think more in terms of when does Clean Water Act jurisdiction exist. And particularly with Maui County, that gives you a lot of room to think less about what exactly the water of the United States is and more about what a discharge of a pollutant as a whole is. And that also, I think, leaves a lot of room in context to think about the real differently resonant legal webs that those two permit programs operate in, and to think more holistically about, like I said, what a discharge of a pollutant is rather than whether a puddle should be a water of the United States or not. So.
Thanks. Thanks so much for the presentations today. They were great. And I had two questions for Sheila. Sheila, I don't know if you can see me. This is Dave Kaiser. Had two questions for you. One, I was curious about, I really enjoyed your paper on Tampa Bay and nutrients, and I was curious about what your thoughts are for how the large benefits you estimate there compared to the costs help inform our understanding of benefit-cost ratios in other water quality policies and programs, and if we can think a little bit more about that. And then second, I don't want to bore people about questions about economic methodologies, but I was curious about your comment on hedonics, and was curious if you could talk, and we can talk offline too, but I was curious about your thoughts on the appropriateness of hedonics as they relate to measuring the benefits of water quality. And it made me think a little bit about Nick Kumanoff's work comparing the benefits of the Clean Air Act using hedonics as well as value statistical lives and dose response functions, and he finds very different benefits with hedonics versus using the value statistical life, but it still seemed like there was a role for hedonics to play in air quality, so I was curious about your thoughts on those two questions. Thanks.
Yeah, thanks so much. So I'll be really quick. So the first, hi Dave, first of all. The second, in Tampa, so what we did was really kind of pilot this new approach where we try to, understand where people recreate and then incorporate that into the property value impacts of water pollution. And we got these very big numbers relative to not worrying about that. And, on the one hand, Tampa is like the kind of aquatic economy there is huge, right? So we're talking about second biggest coast, city on the Gulf Coast. Houston is the next one, but Houston's not really right on the coast, right? So you have lots of coastal property, super active housing market, tons of recreational fishing, right? So, I would hesitate to say, right, that the result there should, generalize elsewhere. But if you look, right, at the location of all of those kind of hypoxic areas on the West Coast, it's pretty ubiquitous. And a lot, as you pointed out in your own work, a lot of the U.S. population lives close to coasts and rivers, right? So, on these important, kind of waterways. So, my view is that we should think about this, right? We kind of need to get it right because it could be the scale of that difference, right, for accounting for these recreational behaviors could be really large. And then to answer your second question, it's funny, I think, if we think about the context of damages that are estimated from pollution in the air context, the absolute lion's share is health damages, right? So, if you look at, the PM 2.5 NAC standard or something like that, it's 95 or more %, right, of the damages, from PM 2.5 that economists estimated are about premature mortality, morbidity, and so on. And in the, I think I would expect to see, property value studies, like in theory, those could be picking up health impacts to the extent that people understand them, right, and really understand kind of what that exposure means. But, you might ask questions about that. Do they really, right? And, so the property value, maybe those are, picking, up more things like visibility and, kind of amenity values and so on and so forth. Whereas in the water quality context, in a place like the U.S. where our water quality on the whole is good, taking aside, right, all the impaired waters statistics that Professor Brett was showing and so on, those are important numbers. But if you, think about the lion's share of damages from water pollution in the U.S. context are probably not those health effects. And there, I think, like, the hedonic approach is a good one, right? So, like, a lot of what people care about, with respect to, to water quality is recreational opportunities, what the water looks like and smells like, how they experience, kind of the environment when they walk out of their house and so on. Again, that is not to say that there aren't important health effects. If you're talking about drinking water, that's a whole other story, right, with lead and those kinds of pollutants. So I actually think it's pretty appropriate in the water quality context, and we could capture a large share of, the damages from pollution using those methods if we get them right.
Thank you. I have a question for Sheila, which is gonna, I think, be a slight follow-up to David's question on economic methodologies. And I am wondering, within the context that the Biden administration has directed the OMB to, in one way or form, suggest or recommend ways for the economic methodologies to account for distribution and distributive concerns. Can the hedonic property model has enough wiggle room to maybe account for some distributive issues, or maybe it already does it? For instance, like based on location of property and disproportionate exposure and the relationship of both?
That's a great question. What I would say is it can. I don't think that we've used it very well to do that, right? To look at those kinds of questions. Certainly in my own work, I haven't. But you can look at, right, once you understand what the impacts are on property values, you can look at that by neighborhood, right, by, SES by neighborhood, by race by neighborhood, and so on and so forth. So it can be used for that purpose. I mean, I think one of the challenges is that if we look at property values, and this comes up in contexts like, flood buyouts and, kind of floodplain buyouts and, all kinds of other environmental contexts, which is that, my house in Austin, right, is located in a neighborhood that has very high property values and didn't when I got here, but it does now. And so, if I'm looking at property value impacts and I'm looking sort of in absolute terms, right, property value impacts of water pollution in places where property values are high and water pollution is low, right, you could get these significant impacts relative to neighborhoods where, right, property values are low from a starting point, and maybe get a smaller absolute number. So if you're standards, right, you could miss, the picture of, hey, this neighborhood has been, really strongly impacted on a percentage basis, right? Sort of thinking about a share of the value of the property. And we don't really see hedonic studies that do that kind of work. And I think it's a great point because we could do a much better job at that.
Thanks. And I just want to say this panel is like a feast. I mean, there's like so many things I want to talk about that I can, but I super, super appreciate it. I think the conversation about hedonic modeling, I think, is very important. There was an analysis done of the impact, the economic benefits of the Great Lakes Restoration Initiative here in this region. And what we hit hard was the only, quote unquote, acceptable analysis was a hedonic analysis. And the challenge with that is the only values that count are the people who own real estate. The economic impacts to others are never accounted for. And so, one of the things I've seen in the economic analysis for setting human health criteria in water quality standards is looking at health impacts for people who have disproportionate exposures. And I think that's something we really need to continue to push ourselves, is how do we account for the impacts that are not affected by real estate? Because so many times we are baking into the system these impacts that never get addressed. So I think it's a great conversation and really appreciate it. And the other thing I can't help offering in the TMDL context is, as you look at those, how many of them were driven by litigation by environmental organizations? Because many, and I'm saying this in my context as a funder, right? Getting a TMDL is a pelt on the wall. The impact of that TMDL is much less significant. And so it's another thing to look, I'm really curious about, is when does a TMDL, is it driven by a water quality concern that's locally driven? And when is it a pelt on the wall for a funded advocate? So sometimes there's overlap, but sometimes there's less. So thanks.
So I guess this is mainly a question and comment, I guess, for Robin, but I've waded through, I think, all the major briefs so far filed in the Sackett case. And I guess, and there's one, in your slide, you indicated, I think the way you highlighted it, it was significant that it was across the road or something, I can't remember the exact phrase. And just, I think one big target of the people pushing the Sackett case is to throw out a long-standing aspect on the Clean Water Act, which is human-built impoundments, blockages, roads, drains. None of them change something from being a water. And that's been in the regs since at least '86, and I think it might have been earlier. And so that's a big part in the brief, because the Sacketts and others keep emphasizing that, saying, and there's a road. Well, that has for about 50 years been completely irrelevant. If it's a water and people build a road, they build a tunnel. And the same thing is true for piping, which came up in the Rapanos case. And Solicitor General Clement said to Scalia, the fact that waters are piped cannot destroy jurisdiction because every city has rivers piped at some point. So that can't be. And Scalia flung himself back in a very frustrated look. But so I guess I just would be careful about, I don't know where you go with that, but I don't think that should matter unless you're going to say that long-standing legal irrelevance of because otherwise it's like Maui. Otherwise, you just build a barrier, you sever the connection, no more jurisdiction. And I don't think that should be so. I think that shouldn't matter.
I agree that it shouldn't. My point was rather the Ninth Circuit had a rather lengthy and somewhat convoluted explanation of why there was a significant nexus. Particularly when you compare it to the district court that just said, yeah, it's directly connected by subsurface flow, we're done. And I guess I would frame it more of, not that I disagree with you, and I hope we don't get rid of the barrier, but facing this court, how many of these fights do you want to be fighting at the same time? In terms of what counts and what doesn't. And maybe they end up having to fight all of them, and hopefully that long-standing interpretation will stand. But I think a lot of people would count it as a win if you just got the court to say there's a subsurface water connection and that's good enough. as opposed to what they might say on every step of that analysis. So, like I said, the point wasn't that I don't disagree with you. I do agree with you that has been the rule and should remain the rule. But in the context of litigation before this court on a question focusing on wetlands, what battles are not predictably the way they've always been, and I think that might be one of them. So I hope not, but I can count to 5, so you know.
All right, I think that we are prepared to.
Awesome.
Oh, do you have a question?
We got a couple more minutes. I'm going to ask a question. So I have an answer to this question, I think, but I'm curious what any of the panelists would say to this hypothetical. We look at the various federal environmental laws, and I think there's a fairly broad consensus that, at least as measured through cost effectiveness and cost benefit studies, the Clean Air Act is at the top of the list. Multiple Clean Air Act regulations are identified as the most cost beneficial federal environmental interventions in the nation's history. There's some recent work, David's done some, other folks have done some, suggesting that at least based on what we've done and what we've been able to measure, we're not so sure about the Clean Water Act in terms of its cost effectiveness or how cost beneficial some of the interventions have been. And certainly that may be a limitation, as has been discussed, with what we can measure. But I'm curious what the panelists how they would respond to someone who just looks at some of that research and says, maybe the Clean Water Act should look more like the Clean Air Act, and maybe the way we try and enlist state and local governments and the way we try and deal with high numbers of dispersed sources that overall contribute to quality levels that we are concerned about, maybe that figuring out how to make the Clean Water Act look more like the Clean Air Act would be a way to make it be more effective at achieving its goals. And I'd be curious what any of the panelists, how they would respond to that suggestion.
Okay, I'll take a first crack. I'll go back to my point. Air is more similar place to place than water is. And so if you were going to do a strict analogy and set ambient water quality standards for the entire country, that means the pristine mountain stream in Idaho and the Mississippi River have to have the same water quality, and they never did. They never will. They can't in their most natural condition. So I think that's just a reality of the two media, that you can't think about water the same way you think about air. And pollutants don't travel as ubiquitously through water. I mean, water goes certain places as it does through air. So I don't think you could do it rationally. But I also think when you're thinking about the costs of the benefits of the Clean Water Act in economic terms, it suffers from the fact that we also have a Safe Drinking Water Act, and the linking of those two, and I'm going to pull on the recent Iowa cases where it's the water quality treatment plants that are suing mostly agriculture pollution because of the increased cost of water treatment. If you don't get that link in the mix of doing the economic benefit analysis of the Clean Water Act, that you are actually saving money in drinking water treatment if the water's cleaner going in to begin with, you miss a lot of what the Clean Water Act is doing. And we also forget that it took a lot of raw, untreated sewage out of our waters as well, and that's really, it's difficult to quantify, but it is a huge economic and health benefit both. So I personally think that's what's been missing in a lot of the economic analyses of the Clean Water Act, is it does, done right, pre-treat our drinking water, but all the benefits of drinking water tend to be put on the Safe Drinking Water Act, and oh, look, it's doing this great thing of improving our health. And it's like, well, yeah, but some of that is because it was cleaner water going in. So, my waxing poetic.
I'm happy to take a crack too, but Professor Brett, did you want to go first?
I'll let you go ahead.
Okay, so just I think this is a great question. I think it's an important one. I would give you 3 reasons to kind of maybe withhold judgment about whether on the whole this is a true statement or not, right? That the water quality regulations, ambient water quality regulations, tend to have lower benefit cost ratios than air quality regulations do. The first is that I agree 100% with Professor Craig's statement. I would also just add that it's likely that a lot of the kind of mitigation measures one might put into place to reduce some of those drinking water impacts, like in the Ottawa case, are a heck of a lot cheaper to do in ambient, right, to sort of prevent that from going into the ambient water, water than it is once you get to the drinking water treatment stage. So, right, even thinking of more creative ways of sort of linking the 2 acts, right, in a sort of cost-benefit framework would be smart. 2, I do think we have a kind of mismeasurement challenge, and that economists just haven't focused on water pollution for very long. I mean, there's some old contributions in the 70s and the 80s, and then there's a long period where there's this very heavy focus on air pollution. And so Dave's work and others, right, kind of really trying to hammer on understanding this is so important, because we don't have a great understanding, I think, of what those the damages are, conversely what the benefits of control are. And the third is that, given the left out sectors here, right, primarily agriculture, but others, atmospheric deposition, as Professor Craig pointed out, a lot of those reductions that have been achieved are excessively costly, right, because we've only targeted on the, on sort of reductions that are quite costly. So it's a little unfair to sort of put that on water pollution itself, right, and say, oh, look, it's really costly to reduce water pollution relative to the benefits. Well, that's because of a set of choices that we've made and continue to make, right, about what sources what we require to control. And so it's not about, right, something inherent in water pollution itself in comparison to air pollution. So fix those problems, and then we can talk. So then one last quick point, because I don't think we fully addressed the question about environmental justice that came up, and I think it's important. I would say that the point about hedonic analysis, only looking at improvements for property owners, 100% agree with that. We have lots of evaluation tools in economics, and many problems require the use of more than one, and water pollution is put in that boat. It's super important, and maybe even a little worse than what you stated, because as property values go up, that's really good for property owners. It's not so good for renters, right? So there's a lot of, focus on environmental gentrification and what the costs are for disproportionately exposed communities. So that's a great important point, and that's it.
Nothing to add? Okay.
Those are great responses.
All right, well, I want to give a big round of applause for this.